Well, hello everybody, and welcome back to another edition of TelescopeMan. Well, I had one of my subscribers suggest a video for the new hams about placement of an antenna on a vehicle and kind of a discussion of omnidirectional antennas versus directional antennas. And so that's what we're going to try to do today. It's going to be a combination of a little show and tell that I'm going to do here in a minute. And then we're going to jump on the computer and I'm going to talk about some of the links and pictures that I have up on the computer right now once we finish the little show and tell. So let's get going, and hey, don't laugh at my representation of a car, okay? Anyway, here is an example of a omnidirectional antenna. And of course, they come in various lengths. The one I've got is GP9, Comet GP9, and it's 17 feet tall. But this is one similar to what you would probably mount on a car or a truck somewhere. You might pick a little bit longer length, half wave or something, but might even put a full wave on there. That's what you find on a lot of military vehicles. Remember those big long whip antennas that they would put on military Jeeps, and they kind of tie them down to the front of the Jeep? Well, those were full wave antennas with that long whip on it. Anyway, here's a representation of a vertical antenna. Now, a little later, I'll show you an illustration of when you key the radio, where do the radio signals go and what that looks like. But let's pretend that we have a ground plane. All right, don't laugh at me. We have a ground plane under this antenna, which could be a car, for example. And if this was the car, if it was a round car, and I put this antenna right here in the middle, that signal is going to go out equally in all directions. No problem whatsoever. Signal will reach equally in all directions. So let's kind of change the shape of this car. Again, don't laugh at my car. Okay, here we have a car. This is the front of the car. This is the back of the car. And I know some cars that look exactly like this. In fact, I had one, a 1962 Chevy 2. It looked just like this. Anyway, on my car, I have the antenna mounted right there on the left side of the trunk lid. Remember, this is the front, this is the back. The driver sits right here. So where do you think the signal is going now, for the most part? It's going in that direction, where the most metal is. That's where it's going. So the signal will be stronger in that direction than this direction. It'll still go out. You will be able to make a contact over here somewhere, but the main signal is going kind of out the right side of the car. Now that's all things being equal, which are never the case in amateur radio. There could be something interfering with the pattern of this antenna, and that it won't be perfectly like an oblong ball in this direction. Won't be perfect. In the real world, it's never perfect. So if I was to mount it, well, the other thing I need to mention is when you mount it here, you're going to lose some dB. I was looking at a chart, and I think it said it was about a -2 dB loss in this position. If I mounted it perfectly in the center of the car, it would be a 0.0 dB loss, okay? But remember, that loss is kind of a calculation being done because the signals coming out here are not as strong as the ones coming out toward the front. So I wouldn't, I'm sure that's correct as a calculation, but again, practicality, I mounted it here for 2 reasons. It was the simplest way to mount it on my car, which is a lease vehicle. Not going to drill a hole in a lease vehicle. And if I mounted it right there on the front edge of the trunk lid, which would have given me less of a dB loss because I got more metal now behind it. Whenever I opened the trunk, the antenna would hit the car. Couldn't mount it there. So I selected this area on the trunk lid. Now, the other reason I mounted it there is when people see it mounted there, they really don't know it's a amateur radio antenna. They think it's a regular car radio antenna because that's where, a few years back when you had an AM FM radio in the car, they would mount the antenna in about that position on the car. Sometimes they'd mount it up here on the front, but more than likely they would mount it on the back here. It just looked better. So a lot of people think this is just a regular radio antenna. Kind of keeps the radio a little bit safer in the car. They don't realize there's a radio in the car. Again, the best position is right there in the center of the roof. Okay, but that's not always possible with your car or with your truck. It's always possible, but the question becomes, do you want to drill a hole and run that cable down through the roof? That's the question. Only you can answer that. In my case, I put it back here. So just keep that in mind when you're mounting your antenna to whatever it is you're mounting it to, that the signal will go in the direction where there's the most metal. That's a simple way to put it. So more signal, if I had it here in the middle of the trunk, or let's say in the bed of a pickup truck, and I'm going to assume you've got this antenna above the roof some kind of way. Because if it's behind the window of the pickup, the window of the pickup is right here and there's metal right here, you're going to basically interfere with the signal going this way. It's going to have to go through, it's not going to go through that metal. It's going to change the lobes, the omnidirectional lobe on this antenna. So it really needs to be above the metal of the truck. That's why you see a lot of truck drivers will mount it on the left side rear view mirror above, where it's mostly above the cab. Okay, that's the reason. In that case, if it was mounted on your rear view mirror, the signal's going to go this way more than it goes this way. All right, it'll probably go more in this direction than it even goes in this direction because there's more metal here, that it's got that ground reflection working to your advantage. So just keep that in mind when you mount your antenna. Now, is it a lost cause if you mount it not in the perfect position? Well, no. As I've said, mine is mounted on the left side of the trunk lid, and I can easily reach. Let me give you an example. If I'm traveling toward Dallas, again, in my case, my signal's going forward to the right. If I'm traveling toward Dallas, I can easily reach repeaters that are 45 miles away. So, assuming that they have a fairly good antenna system, which most of the repeaters in Dallas are mounted on a tower on top of a tall building. So, line of sight is good. So with that said, and kind of got you going on positioning the antenna, let's talk a little bit about what does that antenna transmission lobe look like in reality. What does it look like? So let's go back to the computer, and let me get you set up over here. All right, let's start right here. Okay, what you're looking at, and I'll give you some of these links at the bottom of the comments section there. I'll have some links for you. This is simply a Wikipedia link. And what you're looking at is a perfectly omnidirectional antenna pattern. And you can see it looks like a donut. When you see a 2D representation of a pattern, let me kind of show you one of those so you know what I'm talking about, like this. It really doesn't give you the indication of what the pattern actually looks like. Remember, those signals are going up, sideways, down. They're going in all directions. That's why the software, one of the things is the antenna mounted in free space up at least a half a wavelength above the ground, at least. All right, half a wavelength above the ground. That's why they always ask you that in the antenna analyzer, pattern analyzer software. So anyway, an omnidirectional antenna will put out a signal that looks like a donut in all directions. As this is indicating, what you're actually looking at right here, there's signals coming towards you that they can't represent. Here's the antenna. And as you can see, they're radiating in all directions, upward, downward. Only below and above the antenna are there no signals. And even that is not a perfect representation. There are signals there. They're not very strong. It's not an absolute null. Again, nothing is perfect when you're talking about antennas, okay? So you're not going to have a perfect null above an omnidirectional antenna. There is going to be some signal, it won't be very much, but there will be some that's going straight up, but not very much at all. So that kind of represents to you what the signals look like in an omnidirectional antenna. Now, let me kind of back up over here just a little bit. We'll talk just for a minute about a directional antenna. Here is what I would consider a perfect directional antenna. This thing is perfect. It's got a lot of gain in this direction. That's how you read the chart. The gain is going this way. There's a little bit coming off the sides and a little tiny bit coming off the back. Not a whole lot, but a little bit. And you can see the dB ratings here, okay? and but the power is going out in the direction that the Yagi is facing. This is how your TV antennas basically pull in the signal reception-wise when they're pointed at the transmission tower, because they have a lot of gain in the direction that you've got that Yagi TV antenna pointed. Another thing you can determine from this chart is the spread of the beam. How wide is the beam? And the normal way they do that is they come down 3 dB from the peak reading and measure the angle. So let me show you that. So here's the 3 dB circle right here. So let's come around. So from right there to right there, that angle going out is the beam width that in ideal situations, perfect situations, that's what that beam will represent. Now, most of the manufacturers will have some kind of an antenna chart that you can look at that shows the pattern of the antenna in this fashion. Not all of them, but some of them do, especially the people that build amateur radio beam antennas. They almost always have a chart like this that shows you what the pattern will be of the beam. But what I want to get over to you is in this two-dimensional representation, you're not seeing the donut that's actually occurring, okay? So let's look at the donut now. All right, here's that same beam antenna, but now look at the lobes, the transmission lobes. And again, the bigger the lobe is, the more power is going that way. You can see these little side nodes on this antenna, this pattern. These little side nodes are actually going in all directions. They actually go in every direction. All right, and the main transmission gain is to the front of the beam, but you know, there's some going up, you know, some going down. Some of those may bounce off the ground and go back up again, and basically have multi-mode antenna emission, where one, there's a strange effect where you get an echo in your transmission from a signal that arrived at a later time. I've heard it once or twice. This is reflected signals that are not part of the main signal coming off the antenna. That's just a strange effect of radio waves. So anyway, just keep in mind when you look at a pattern like this, you got to kind of expand your mind and realize that it's not a pattern like that, but it's more like a donut like this. Okay? It's a donut, depending on the type of antenna. That donut will be misshapen based on the location of the antenna, what's around it. Is it coupling to something like a metal roof that's not too far away? Or a brick home that's not too far away? Is that affecting the gain in that direction? Well, yes, it is. And I always joke and say my beam antenna probably looks something like this, rather than that nice, pretty illustration that I showed you a minute ago. My beam probably looks something like this. You know, I've got a house on one side of the beam, So probably I'm attenuating those signals in some fashion off of that house, even though I'm above the house. You know, and maybe one of the elements in the middle is hanging down a little bit more than it should be from the one on the other side. And I might have more gain going out in this direction than I do in this direction off the side of the beam, because those elements are sagging down a little bit too far. You know, and the pattern to the rear is also affected by the design of the beam and the objects around it. So, you know, I am not expecting my beam to look like that. It will never look like that in the real world. Oh, I suppose you could get it to look like that. You know, if you put it up 100 feet in the air where it's absolutely in clear space, free space, and you really worked on the antenna to get everything absolutely perfectly, but that's really a waste of time. It's not really going to gain you anything. So, what does my beam look like? Well, here's my QSL card. If I can get it right here. There's my card and there's my beam. You can see we're doing a little work on it. It's a 4-band Mosley 33TA. And what we did is we mounted a 40-meter kit on the center driven element. And you notice how long it is. It's longer than even the direction element, the reflector. It's even longer than that, and so it sticks out because it's operates as a rotatable dipole on 40 meters. So this beam will work 10, 15, 20, and 40. Anyway, that's a Yagi. The other little comment I want to make to you is when you're talking antennas, and I know you really won't run into this very much in a car, but once you get out of a car and you're talking about antennas that may be set up in the backyard 100 feet away from your radio or 50 feet away from your radio, you need to spend a little time with a Coax ratings chart and look at the various types of coax and how much loss they have, okay? Because if you're going to use RG58 for everything, well, your radio will definitely start losing power to the antenna once you get beyond about 30 feet to 50 feet. You get beyond that, and it's now the full power of the radio is not going to make it to the antenna. It's going to be lost in the coax. So you really need to pick your coax. And very quickly, I always recommend two kinds of coax. For HF, I always recommend RG213. And for VHF, UHF, I always recommend LMR 400. If you'll stick with those two, you're going to be in fine shape. No matter what kind of equipment, amplifiers, or anything else that you wind up putting in the ham shack. So be sure you take a look at coax, and it's part of the entire antenna setup. Don't ignore it and spend all your time and effort and money on just an antenna. Think about the coax that's attached to that antenna just a little bit, and you'll find you've got a better signal and better reception even. And good coax is less influenced by RFI that may be around you. Basically can't get through the shielding, the better shielding of good coax versus cheap coax. That can help you with some of your RFI problems. Anyway, with that said, let me get you back on me. I think this video went long enough now. And if I can click the right button, there we go. Well, I hope that helped you just a little bit understand about antenna lobes and the direction of travel depending on where you mount your antenna on your car. Now, it's not a game changer. I mean, don't, oh Lord, I've got to mount it on the back of the trunk. I'm not going to be able to get out. Well, that's not true. You will be able to get out. Just remember that you might be able to get out just a little bit further if you have it mounted on the left side of the trunk lid like I do, toward the front right side of the car. That's your main lobe. Anyway, with that said, as I usually do, I wish you clear skies and 73, and keep looking up to see the greatest show on earth right over your head every single night. Hope this helped you. Hope it wasn't too long. Give me your comments and subscribe. See y'all later.